Good morning, students. In the last class, we are discussing about the energy, that is kinetic energy. So, one more relation we have, relation between kinetic energy and momentum. So, this is also important for 1 marks and right. So, we have to relate the relation between the kinetic energy and momentum, right? So, we know kinetic energy is given by k is equals to half m v square, where m is the mass of the object and v is the velocity of the object, right? So, in the right hand side, multiplied and divided by m. So, mass in the multiply method divide. So, if we cancel these two, again we get 1 into half m v square, we get the same relation, that is kinetic energy, right? So now kinetic energy k is equals to 1 by 2. So m into m square v square divided by m, right? So we know momentum is denoted by p, that is equals to, it is the product of mass into velocity of the object, right? So substitute here. So this we can write 1 by 2 mv whole square divided by m. So substitute mv by p, right? So we get k is equals to half p square divided by m, right? So this is the relation for the kinetic energy and momentum. So it is a important relation. Even in second year also we carry this relation. Relation between the energy and momentum means kinetic energy is equals to square of the momentum divided by 2m, where 2 is constant and m is constant. So ನಮಗೆ 2 constant ಇರುತ್ತೆ, mass of the object ಕೂಡ ಏನಿರುತ್ತೆ constant ಇರುತ್ತೆ. Because moving objects ಅಲ್ಲಿ mass ಏನಾಗೋದಿಲ್ಲ, ನಮಗೆ change ಆಗಲ್ಲ. So kinetic energy is directly relates with the square of the momentum, or momentum is directly with the square root of kinetic energy, right? So this is the relation for the kinetic energy and momentum. So 1 marks ge tumba important. So write the relation between kinetic energy and momentum means you need to write the relation and we need to explain the terms, where p is the momentum, where m is the mass of the object, right? So next, potential energy. So it is also similar to the of the kinetic energy. So kinetic energy is energy possessed by a body during its motion. We call that one as kinetic energy. So here potential energy possessed by a body due to its position or due to its configuration, that we call as the potential energy, right? So potential energy, the energy possessed by an object due to its position means height, due to its position or configuration. So configuration means shape. So say shape of the object ಮೇಲೆ ಕೂಡ depend ಆಗಿರುತ್ತೆ. That we call as the potential energy, right? So what is potential energy means energy possessed by a body due to its position or due to its configuration. So that we call as potential energy, right? So it is also called as stored energy, right? So potential energy is also called as stored energy, right? So potential energy na ನಾವೇನಂತ ಕರೀತೀವಿ, stored energy ಅಂತಲೂ correctly, right? So this gives the definition of the potential and energy. So SI unit remains same. So kinetic energy gain SI unit iruttho, that will be the same for the potential energy, right? So example for the potential energy: water stored in a reservoir, right? So water, ಯಾವುದಾದ್ರೂ ಒಂದು ಡ್ಯಾಮ್ ಅಲ್ಲಿ ವಾಟರ್ ಸ್ಟೋರ್ ಆಗಿದೆ ಅಂದ್ರೆ, so that possesses the potential energy. And similar example, water stored in a overhead ಟ್ಯಾಂಕ್. ಸೊ ಮನೆ ಮೇಲೆ ಟ್ಯಾಂಕ್ ಫಿಕ್ಸ್ ಮಾಡಿರ್ತಾರಲ್ಲ, ಆ ಟ್ಯಾಂಕ್ ಅಲ್ಲಿ ನೀರು ಸ್ಟೋರ್ ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದನ್ನು ಕೂಡ ನಾವೇನಂತ ಕರಿತೀವಿ, ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ, ರೈಟ್? ಸೊ ಇದು ನಿಮಗೆ ಹೈಸ್ಕೂಲ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದೀರಾ, ಡೆಫಿನೇಷನ್, ಎಕ್ಸಾಂಪಲ್, ಆಲ್ ದಿಸ್, ರೈಟ್? ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ. Right? So first one is gravitational potential energy. So first one is the gravitational potential energy, and the second one is elastic potential energy. We have two types of potential energy. We are going to discuss on these two topics in this chapter, right? So one is gravitational potential energy and another one is the elastic potential energy. So again, if we define for the gravitational potential energy, the energy possessed by the object due to its position, only due to its position, that the height of the object from the surface of the earth, so that type of energy we call as the gravitational potential energy. So definition same irutte. Illi ನಾವು ಎರಡು consider ಮಾಡಿದ್ವಿ. One is position and another one is the configuration. So gravitational potential energy define ಮಾಡೋದು ಹೆಂಗೆ ಅಂದ್ರೆ, so energy possessed by an object due to its position only, right? Due to its position, or we call that one as height of the object above the earth surface. So this is what the definition of the gravitational potential energy. Gravitational potential energy is defined as energy possessed by an object due to its position, right? So due to its position, so that energy we call as gravitational potential energy, right? So next, elastic potential energy, it is also similar way, right? So energy possessed by an object due to its configuration, that means the shape of the object. So object shape change agtide andre, so there is some energy, so that object possesses some energy, so that energy we call as elastic potential energy, right? So elastic potential energy is defined as the energy possessed by an object due to its configuration. Configuration is nothing but shape of the object. Shape means either it may be compressed or it may be elongation. So compress ಆಗಬಹುದು ಅಥವಾ elongation ಆದ್ರೂ ಆಗಬಹುದು. So it means compress ಆಗ್ತಿದೆ ಅಂದ್ರೆ shape of the object ಏನಾಗ್ತಿದೆ, change ಆಗ್ತಿದೆ. elongation ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಕೂಡ ಏನಾಗ್ತಿದೆ, ನಮಗೆ shape of the object ಏನಾಗ್ತಿದೆ, change ಆಗ್ತಿದೆ. That means configuration change ಆಗ್ತಿದೆ. Configuration change ಆಗ್ತಿದೆ ಅಂದ್ರೆ there is some energy, that means that object possesses some energy, so that energy we call as elastic potential energy, right? So ಎರಡು important. So ಈ chapter we are going to discuss on these two topics. So ಇಲ್ಲಿವರೆಗೂ ನೀವು ಹೈ ಸ್ಕೂಲ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, definition, then example, right? So mostly you need to concentrate on these two topics. So one is gravitational potential energy and another one is elastic potential energy. Let's discuss one by one. Gravitational potential energy, that means we need to write the mathematical relation for gravitational potential energy and elastic potential energy, right? gravitational potential energy, right? So definition in it is the energy possessed by the object due to its position. That means position means only it varies with the height change ಆದರೆ ಮಾತ್ರ that object possesses some energy. So ಅಂತ energy ಏನಂತ ಕರಿತೀವಿ ನಾವು gravitational potential energy ಅಂತ ಕರಿತೀವಿ, right? So consider one object of mass m, right? So consider an object of mass m. Initially it is on the surface of the earth. So in line ನಾವು ground ಅಂತ consider ಮಾಡಿದ್ರೆ, so that becomes the surface of the earth, right? So now I am lifting this object. So lift ಮಾಡ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ ಇದನ್ನ ಮೇಲ್ಗಡೆ ಎತ್ತುತ್ತಾ ಇದ್ದೀನಿ, right? So I am lifting this object. So ಈ object ಮೇಲ್ಗಡೆ lift ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ we need to apply some force, right? So ಯಾವುದಾದ್ರೂ ಒಂದು object ನ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ ಇರೋದನ್ನ ಮೇಲ್ಗಡೆ ತಗೊಂಡು ಬರಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, we need to apply the force. So force apply ಮಾಡೋದ್ರೆ ಏನಾಗುತ್ತೆ, we are lifting this object. That means object will move upwards, right? So this is the force which is required to lift the object to a height h. So vertical ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ನಾವು displacement ನ ಏನಂತ ಕರ್ಕೊಂತೀವಿ, height ಅಂತ ಕರ್ಕೊಂತೀವಿ, right? So this force is required to lift the object of mass f, right? So this is the external force f, right? So object ಮೇಲೆ force act ಆಗ್ತಿದೆ. Force act ಆಗ್ತಿರೋದ್ರಿಂದ position of the object ಏನಾಗ್ತಿದೆ, change ಆಗ್ತಿದೆ. Initially ground ಅಲ್ಲಿ ಇರುತ್ತೆ. So force act ಆಗ್ತಿದಂಗೆ it displaces its position to its certain height h. So ground ಅಲ್ಲಿ ಇರೋ object ಏನಾಗುತ್ತೆ, so certain height ಅಷ್ಟು ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ. That is because of the force f, right? So that means f is the applied force, right? So we can write applied force, that is f, right? So ಇಲ್ಲಿ force act ಆಗ್ತಾ ಇದೆ, ಜೊತೆಗೆ displace ಕೂಡ ಆಗ್ತಾ ಇದೆ. So that means work is done by the external force, or we call that one as the applied force, right? So work done by the external force W, that is equals to, so force and displacement both are in the same direction, right? So force upward act ಆಗ್ತದೆ, displacement ಕೂಡ upward direction ಅಲ್ಲೇನೆ its position ಏನಾಗ್ತಿದೆ, change ಆಗ್ತಿದೆ. That means the angle between the force and displacement is 0 degree. So work done formula we have fs cos theta. So cos 0 is 1. So directly we can write f into s, right? So work done is equals to f, fs cos theta, right? So external force and displacement or parallel. So ಅದನ್ನ ನಾವು in the same direction ಅಂತ represent ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕಿಂತ parallel ಅಂತ represent ಮಾಡ್ಕೊಂತೀವಿ, because force ಮತ್ತೆ displacement ಎರಡು parallel ಇದೆ, right? So that means angle theta is equals to 0 degree. So same direction ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ parallel ಆಗಿರುತ್ತೆ. So angle between force and displacement ಏನಿರುತ್ತೆ ನಮಗೆ 0 degree ಇರುತ್ತೆ, right? So work done by the external force ಏನಾಗುತ್ತೆ ನಮಗೆ W, that is equals to F. S in place of S we taken H, right? So force will act ಆಗ್ತಿದೆ ಅಂದ್ರೆ, so this force is balanced by the gravitational force, that is mg, right? So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇದೆ ಅಂದ್ರೆ this force has to be balanced by the another force. So that force is balanced by the weight of the object. So mg ನ ನಾವು ಏನಂತ ಕರೀತಿದೀವಿ, weight of the object ಅಂತ ಕರೀತಿದೀವಿ. So that weight of the object is equals to the gravitational force. We call that one as fg, right? So here from the Newton's third law of motion, f is equals to fg, right? So from Newton's third law, f is equals to fg, that is equals to mg, right? ಸೊ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತಿರೋದ್ರಿಂದ ಎಫ್ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಎಂ ಜಿ ಇರುತ್ತೆ ಬಿಕಾಸ್ ಇದು ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಸೊ ಎಫ್ ಮೈನಸ್ ಎಂ ಜಿ ಏನಾಗುತ್ತೆ ಎಫ್ ಮೈನಸ್ ಎಂ ಜಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು 0 ಸೊ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎಂ ಜಿ right so in place of f we can write that one as w is equals to mgh. So this is the work done by the external force. So e work done na ನಾವು ಏನಂತ ಕರೀತಿದೀವಿ work done by the external force. So ನಾವು ಅಪ್ಲೈ ಮಾಡಿರೋ ಫೋರ್ಸ್ ಇಂದ ವರ್ಕ್ ಆಗ್ತಾ ಇದೆ ಸೊ ಅಂತ ಫೋರ್ಸ್ ನ ಅಂತ ವರ್ಕ್ ಡನ್ ನಾವು ಏನಂತ ಕರೀತಿದೀವಿ work done by the external force. So ಇಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿರೋದು gravitational potential energy, that means work done by the gravitational force, right? So now work done by the gravitational force. So this is the work done by the external force. So now we are going to calculate the work done by the gravitational force. So work done by the gravitational force W is equals to force into displacement, that is which force? That is the gravitational force, right? So gravitational force into displacement and cos of an angle between the gravitational force and to that of the displacement, right? So work done by the gravitational force ಅಂದ್ರೆ ನಮಗೆ ಈ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಏನು ವರ್ಕ್ ಆಗ್ತಾ ಇದೆ ಸೊ ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತಿದೀವಿ gravitational potential energy ಅಂತ ಕರೀತಾ ಇದೀವಿ, right? So Fg is always acting vertically downwards, that is towards the center of the earth ಕಡೆಗೇನೆ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ. ಸೊ ಇದನ್ನ ನಾವು ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ, right? So this Fg is acting vertically downward direction but the displacement is opposite to that of the direction. So displacement upward direction ಇದೆ but work force ಯಾವ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಿದೆ downward direction ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. That means the gravitational force and the displacement are anti-parallel, right? Gravitational force and displacement or anti-parallel. That means angle theta is equals to 180 degree, right? So one vector is acting downward direction, that is force. So another vector is acting upward, that is the displacement. So now body na lift ಮಾಡ್ತಾ ಇರೋದು by the external force, right? So here the two forces are acting. One is the external force, so this is balanced by the gravitational force. So gravitational force is always acting downwards, so that is equals to the weight of the object, right? So that is acting downwards, so displacement is vertically upward, right? So these two are anti-parallel. So anti-parallel means angle theta is 180 degrees, right? So substitute here W is equals to Fg is m into g. So Fg ಏನು ಬರ್ಕೊಂಡಿದೀವಿ ನಾವು m into g. So displacement is h, so cos 180 degree. So cos 180 is minus 1. So work done by the gravitational force is equals to minus mgh. So this work done by the gravitational force is stored as the potential energy. So we call this one as gravitational potential energy. Work done is equals to U. So U means gravitational potential energy. So now potential energy always will be denoted by the letter U. So U ಇಂದ ನಾವು so potential energy na denote ಮಾಡ್ಕೊಂತಿದೀವಿ. So gravitational potential energy, that is W is equals to U, that is equals to minus mgh. So ಎರಡು ನಮಗೆ true when we consider work done by the external force. So ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ ಇಂದ ಏನಾಗ್ತಿದೆ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಫೋರ್ಸ್ ಮತ್ತೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಅವಾಗ ನಮಗೆ ಸಿಗೋ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಏನಿರುತ್ತೆ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಸೊ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ನಮಗೆ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಾಟ್ ಯಾವಾಗಲೂ. ಸೊ ವೆನ್ ವಿ ಲಿಫ್ಟೆಡ್ ಇನ್ ದ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಸೊ ಇಟ್ ಈಸ್ ಮೈನಸ್. ಸೊ ಗ್ರಾವಿಟೇಷನಲ್ potential energy upward direction ಅಲ್ಲಿ ನಾವು ಲಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಮೈನಸ್ ಇರುತ್ತೆ. the same object if it is moving downward, so ಈ ಮೇಲ್ಗಡೆಯಿಂದ ನಾವು ಕೆಳಗಡೆ ತಗೊಂಡ್ಬಂದ್ರೆ so that means force is gravitational force is acting downwards and also the displacement is acting in the downward direction, right? So that means U is equals to mgh. When we taken this object from upward to downward, so ಮೇಲ್ಗಡೆಯಿಂದ ನಾವು ಕೆಳಗಡೆಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ತಗೊಂಡ್ಬಂದ್ರೆ, ಸೊ ಫೋರ್ಸ್ ಮತ್ತೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎರಡು ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಅವಾಗ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. ಸೊ ಅಗೇನ್ ವಿ ಗೆಟಿಂಗ್ ದ ಎನರ್ಜಿ U is equals to mgh, right? So that we call as gravitational potential energy. So e derivation ali, so this we need to write, right? So gravitational potential energy is equals to mgh. So ನೀವು already potential energy, general of potential energy ಅಂದ್ರೆ ನೀವು ಏನು ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, mass into acceleration due to gravity into height. So ಇದನ್ನ ನೀವು ಹೈಸ್ಕೂಲ್ ಅಲ್ಲೂ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, right? ಬಟ್ ಆ ಎನರ್ಜಿನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ದ ಡಿರೈವೇಶನ್ ಫಾರ್ ದ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ, ರೈಟ್? ಸೊ ಡೋಂಟ್ ಕನ್ಫ್ಯೂಸ್ ವಿತ್ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ and to that of the gravitational work. So external work is the force which we applied. So gravitational work is the work done by the weight of the object or force due to the gravity. So next, elastic potential energy. So elastic potential energy, again we define this one as by changing its configuration. So configuration change aaytu andre that object possesses some energy, so that energy we call as elastic potential energy, right? So here consider one spring. So this spring is attached to some mass, right? So when no force is acting on this object, so ಯಾವುದೇ ತರದ್ದು force act ಆಗ್ತಿಲ್ಲ, right? So F external or applied force that is equals to 0, right? So initial case ಅಲ್ಲಿ ಯಾವುದೇ force act ಆಗ್ತಾ ಇಲ್ಲ spring ಮೇಲೆ ಅಥವಾ block ಮೇಲೆ, so this block having mass some m, right? So external force 0 is there, so there is no displacement. So there is no displacement means there is no work done, right? So initially we take on the position of the object, that is x is equals to 0. When applied force is 0, then the initial position of the object is 0, right? So ಇಲ್ಲಿ ನಾವು ಸ್ಪ್ರಿಂಗ್ ಅಂತ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು ಅಥವಾ ಸ್ಪ್ರಿಂಗ್ ಗೆ ಒಂದು ಬ್ಲಾಕ್ ನ ಅಟ್ಯಾಚ್ ಮಾಡಿ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಬಹುದು, right? So now so this block is applied with some external force. That means I am pulling this block. So if block na pull madodre enagutte, it changes its position, so the spring gets elongated, right? So initially object illitu, so after applying the external force, so here I will write F external. So it displaces by some amount, that is x. When an external force is applied, so the object gets displaced from its initial position. We call this position as mean position, right? So ಇದನ್ನ ಫರ್ದರ್ ನಾವು ಮತ್ತೆ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಆಸಿಲೇಷನ್ಸ್ ಅಲ್ಲಿ. ಸೊ ಅಲ್ಲಿ ನಾವು ಇದನ್ನ ಮೀನ್ ಪೊಸಿಷನ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಸ್ಪ್ರಿಂಗ್ ಅಲ್ಲಿ ಆಸಿಲೇಟ್ ಆಗುತ್ತೆ, ಸೊ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ, ಗೆಟ್ ಡಿಸ್ಪ್ಲೇಸಸ್ ಫ್ರಮ್ ಇಟ್ಸ್ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್. ಸೊ ಇಲ್ಲಿ x 0 ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ x ಇರುತ್ತೆ, ದಟ್ ಈಸ್ x minus 0 is again we getting x, right? So that means the shape of the object changes. So ಇಲ್ಲಿ ಸ್ಪ್ರಿಂಗ್ ದು ಶೇಪ್ ಏನಾಗಿದೆ, spring the shape ಏನಾಗಿದೆ ಚೇಂಜ್ ಆಗಿದೆ. when an external force is applied onto this spring, the spring shape get changes. That means spring ಏನಾಗಿದೆ elongate ಆಗಿದೆ. So elongate ಆಗಿದೆ ಅಂದ್ರೆ there is a force. That force we call as the restoring force, and this restoring force is always opposite to that of the applied force. So ಇದನ್ನ ನಾವು last chapter ಅಲ್ಲಿ ಕೂಡ explain ಮಾಡಿದ್ದೇವೆ. So some basic forces, right? So here the restoring force is getting, so that force will be taken as spring force, right? So that spring force Fs is directly relates with the displacement, right? So this spring force is directly relates with the displacement, right? So that displacement is minus because the force and displacement both are in the opposite direction, right? So ನಮಗೆ spring force ಈ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ that is the restoring force is acting towards the left side, then the displacement is towards right side. So ನಮಗೆ right side ಅಲ್ಲಿ displacement ಆಗಿದೆ, left side ಅಲ್ಲಿ ನಮಗೆ spring force act ಆಗ್ತಿರುತ್ತೆ. So spring force ನ ನಾವು restoring force ಅಂತ ನಾವು ಕರಿತೀವಿ. So here I taken that one as spring force Fs. So Fs is directly relates with the displacement of the object or displacement of the spring, right? So if we remove the proportionality constant, so Fs is equals to minus kx, right? So where k is a constant, so that constant we call as spring constant. Where k call that one as the spring constant, right? So now observe here, the spring force is exactly equal and opposite to the, right? So the applied force F is equals to plus kx. Call this one as first equation, right? So now apply some force, that is external force. So ಸ್ವಲ್ಪ apply ಮಾಡಿದ್ರೆ ನಮಗೆ change in displacement ಎಷ್ಟಿರುತ್ತೆ ಸ್ವಲ್ಪ ಇರುತ್ತೆ. So if I am applying some force, so it changes its position some small amount. We initially taken that small amount as delta x or dx, right? So small change in displacement means there is a small work done by the spring, right? So small work or work done by the spring, right? For a small displacement we get small change, that is dw, right? So dw that is equals to again F into delta x again cos theta. So this is from the definition of the work done. So F is the force which we are applied, so that force we call as the external force, F external, right? So here also we will write F external. So delta x is the small change in position. So now initially so force ಒಂದೇ ಸಲ ಇಲ್ಲಿದ್ದು ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಲ್ಲ. So small amount ಅಷ್ಟು ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಡಿಸ್ಪ್ಲೇಸ್ ಆಗ್ತಾ ಇದೆ. So for initially we considering for the small change, so small change ಆಗ್ತಿದೆ ಅಂದ್ರೆ there is a small change in work done. So ಸ್ವಲ್ಪ ಡಿಸ್ಪ್ಲೇಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಸ್ವಲ್ಪ work done ಆಗುತ್ತೆ. So ಜಾಸ್ತಿ ಡಿಸ್ಪ್ಲೇಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಜಾಸ್ತಿ work done ಆಗುತ್ತೆ, right? So again the external force and the displacement both are in the same direction, right? So now apply ಮಾಡಿರೋ force ಕೂಡ ಮತ್ತೆ displacement ಎರಡು same direction ಇರೋದ್ರಿಂದ so theta value ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಆಗುತ್ತೆ, right? So dw that is equals to F external into delta x because theta is equals to 0 degree. External force and displacement both are in the same direction, right? So ಇಲ್ಲಿ observe ಮಾಡಬಹುದು. So this is the displacement x and F external. So ಎರಡು ಕೂಡ ಏನಿದೆ ನಮಗೆ same direction, right? So for the total work done, right? So total work done we need to integrate. So integrating dw that is equals to integration of F external delta x. So that is from 0 to x. So limit ಅಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೂ ಇರುತ್ತೆ ನಮಗೆ 0 to x ವರೆಗೂ ಲಿಮಿಟ್ ಇರುತ್ತೆ, right? So from equation 1 we can write, here we get in the LHS w 0 to x. So from equation 1 F external we can written as kx into delta x or dx. joules, right? So this gives what the total work done. So total work done from 0 to x work now work done calculate madudre. That work done gives what the total work done, right? So if we integrate this, we get W is equals to, so k is constant keeping outside, so integration of x dx, that is x square divided by 2, limits 0 from x. So limit ಎಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೂ ಇರುತ್ತೆ ನಮಗೆ, we need to calculate the work done from 0 to x. So limit starts from 0, that is mean position, to the extreme position. So ಈ position ನ ಏನು ಕರಿತೀವಿ, extreme position ಅಂತ ಕರಿತೀವಿ, right? So substituting the limits k by 2, so first we need to substitute the upper limit minus lower limit, right? So work done W is equals to kx square divided by 2. So this work done by the spring stores as potential energy, right? So work done, that is equals to potential energy, that is equals to kx square by 2. So this is the relation for the potential energy in a spring, right? So potential energy andre always you can't take mgh, right? So ಬೇರೆ cases ಅಲ್ಲಿ ಇದ್ದಾಗ ನಮಗೆ potential energy ಬೇರೆ relations ಇರುತ್ತೆ. So up to now you studied only this formula, potential energy ಅಂದ ತಕ್ಷಣ mgh ಅಂತ substitute ಮಾಡಿ simplify ಮಾಡಂಗಿಲ್ಲ, and in mind ಅಲ್ಲಿ ಕೂಡ only mgh potential energy ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಂಗಿಲ್ಲ, right? So potential energy in case of spring we have the relation kx square by 2. So ಇದು similar to that of half mv square ಇದೆ, ಹಂಗಂತ ಹೇಳ್ಬಿಟ್ಟು ಇದು ನೋಡಿದ ತಕ್ಷಣನೇ ಏನಂತ ಕರೆಯಂಗಿಲ್ಲ, kinetic energy ಅಂತ ಕರೆಯಂಗಿಲ್ಲ. So kinetic energy relation ಏನಿದೆ, half mv square. So ಇಲ್ಲಿ ಏನಿದೆ ನಮಗೆ half kx square. So almost ಎರಡು ಕೂಡ ಸೇಮ್ ತರ ಕಾಣಿಸುತ್ತೆ, right? So but this is kinetic energy, half kx square is the potential energy, that is in case of elastic. That means ಯಾವುದಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ದು ಶೇಪ್ ಚೇಂಜ್ ಆಗ್ತಿದ್ರೆ, ಶೇಪ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದ್ರೆ, ಸೊ ಅಂತ ಕಡೆಗೆ ಅಂತ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ, ಎನರ್ಜಿನ ಪೊಸೆಸ್ ಮಾಡುತ್ತೆ, ಅಂದ್ರೆ it gains some energy. So that energy we call as potential energy, that is the elastic potential energy, and the relation is half kx square or kx square by 2. So ತುಂಬಾ important relation. So next chapters allu ನಾವು ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So this chapter, that is this topic, again we will study in oscillations. So oscillations again we study ಮಾಡ್ತೀವಿ, ಅಲ್ಲಿ directly we use this relation, ಮತ್ತೆ ಅದನ್ನ ಇಷ್ಟು derivation ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ, right? So ಎಲ್ಲದನ್ನು ನೆನಪಲ್ಲಿ ಇರಬೇಕು, right? So if we plot the graph for this against force and displacement, so this one is f x, so again minus f minus x, right? Plotting the graph for force and displacement ಇಲ್ಲದನ್ನೇ ಮಾಡ್ತಾ ಇರೋದು. So object ಮೇಲೆ force apply ಮಾಡ್ತಾ ಇದೀವಿ, displace ಆಗಿದೆ, right? So spring force ಗೆ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದು ಏನಿದೆ ನಮಗೆ ರಿಲೇಷನ್ Fs is equals to minus kx, right? So if we put the value for where k is a constant, right? So force ಗೆ ನಾವು value ಕೊಟ್ರೆ, for example force value is 1, that means x value is minus 1, right? So force ಗೆ 2 ಕೊಟ್ರೆ x value ಏನಾಗುತ್ತೆ minus 2. So force ಗೆ 3 ಕೊಟ್ರೆ x value minus 2, and so on. So if we plot the curve for this one, so force is along y axis and x is along x axis. X nothing but displacement, otherwise don't confuse. Yes. So force positive value ಇದೆ, displacement negative value ಇದೆ. So graph, basic graph ನೀವು plot ಮಾಡಿದ್ರೆ ಯಾವ ತರ plot ಮಾಡ್ತೀರಾ? Force positive, so this is 1 2 3 minus 1 minus 2 minus 3, right? So force value is plus 1, x value is minus 1, so you get 1 comma minus 1. sorry, minus 1 comma 1, right? So you know points name baribodu minus 1 comma 1 x comma y minus 2 comma 2 next minus 3 comma 3. So 10th ಅಲ್ಲಿ ಎಲ್ಲಿವರೆಗೂ ಗ್ರಾಫ್ ಕಲ್ತಿದ್ದೀರಾ ಗೊತ್ತಿಲ್ಲ, ಬಟ್ ಇಲ್ಲಿ ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರಿಬೇಕಾಗಿತ್ತು, ಇಷ್ಟೆಲ್ಲ ನೆಸೆಸಿಟಿ ಇಲ್ಲ, ಇದು ವ್ಯಾಲ್ಯೂಸ್ ನ ಕೊಟ್ಬಿಟ್ಟು. ನೆಕ್ಸ್ಟ್ minus 2 comma 2 means here I am getting minus 2 comma 2. Next minus 3 comma 3, here we getting the curve. So it will continue. So 4 comma minus 4 comma 4 minus 5 comma 5 up to n values. So ಎಲ್ಲಿವರೆಗೂ ಫೋರ್ಸ್ ಕೊಡ್ತಾ ಹೋಗ್ತಿರೋ ಅಲ್ಲಿವರೆಗೂ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. Now joining these points, so these will pass through the origin, right? So straight line passing through the origin. So this curve gives F is equals to minus kx. So this force is which force? So this is the force for the spring force, that is Fs. But ಇಲ್ಲಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದು ಯಾವುದು? ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್. So external force is opposite to that of the spring force, right? So F external we get positive x, that is k into x. So F external is equals to that of the Fs. So it is opposite to that of the spring force. So displacement के values ಕೊಡ್ತಾ ಹೋದ್ರೆ ನಮಗೆ ಏನು ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ? External force. So this force is opposite to that of the spring force. So ಈ force spring force ಗೆ opposite ಯಾವುದು ಇರುತ್ತೆ? External force ಇರುತ್ತೆ. That means curve ಈ ಕಡೆ ಇದೆ ಅಂದ್ರೆ ಇದು opposite ಯಾವ ಕಡೆಗೆ curve ನ ನಾವು ಡ್ರಾ ಮಾಡ್ಕೊಬಹುದು? In this direction. So this gives what? F external, right? So F external is opposite to that of the spring force. So we get a straight line passing through the origin in second quadrant and to that of the fourth quadrant, right? So now work done calculate ಮಾಡೋದಕ್ಕೆ we have the formula. Work done, that is if we plot the graph for force and displacement. So work done gives what? The area under the curve gives what? The displacement. So ಅದನ್ನೇ ನಾವು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ work done ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ವಿ. Area below the curve gives what? The displacement. So ಇಲ್ಲಿವರೆಗೂ ನಾವು force apply ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ, so this is in the form of a triangle, right? So now if we calculate this area, then we get the elastic potential energy or work done, right? So that is work done is equals to half base is what? The displacement, right? Half into base into height, right? So yes, ಬರುತ್ತೆ ನಮಗೆ base. So we have external, this is what? The displacement x. So F external again we have kx into x half kx square. So this we call as potential energy. So iduna ನಾವು mathematically prove ಮಾಡ್ಕೊಂಡಿರೋದು. So this is from the graphical. So graphical ಅಲ್ಲಿ use ಮಾಡ್ಕೊಂಡು we prove that the potential energy, right? So area below the curve is what? The work done, right? So area under the curve gives work done in force displacement graph. So force displacement graph only area under the curve gives what? Displacement. So this is in the form of a triangle. So area of triangle is half into base into height. So height is F external and base is x, right? So F external we have the relation kx. So substitute module half into k into x square. So this is similar what we proved in the mathematical form, right? So this is about the elastic potential energy. So ಎರಡು potential energy ನಾವು ತುಂಬಾ ನೆನಪಿಟ್ಕೋಬೇಕು. One is gravitational potential energy, or simply we call that one as potential energy. So now every time gravitational potential energy ಅಂತ ಕರೆಯಲ್ಲ. So directly we call that one as potential energy, that is equals to mgh, right? So this is based on the situation, right? So situation upward allitto ಅಥವಾ downward allitto ಅನ್ನೋದ್ರ ಮೇಲೆ depend ಆಗುತ್ತೆ. So another one is elastic potential energy, that is UE. So UE represents the elastic potential energy, that is equals to, always it is half kx square, right? So these two are the potential energies, right? So this we also proved in case of compression. So ಇಲ್ಲಿ only elongate ಆಗೋದಲ್ಲ. So in case compress ಆದರೂ ಕೂಡ we get the relation. So this is the main position, right? So this is the displacement. The force applied in this direction, that is F external, and spring force is in this direction, Fs, right? So same derivation ನಾವು in case of compression ನಾವು ಕೂಡ ನಾವು find out ಮಾಡಬಹುದು. So ಯಾವುದಾದರೂ one diagram is enough. So one is when external force 0, when external force is applied. So when external force is applied, it changes its position to the mean position ಇಂದ ಏನಾಗುತ್ತೆ, extreme position ಗೆ change ಆಗುತ್ತೆ. So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, mean position ಅಲ್ಲಿ 0 ಇರುತ್ತೆ. So force apply ಮಾಡಿದ ತಕ್ಷಣ it gets compressed and it changes to the extreme position in the opposite direction, right? So ಇಲ್ಲಿ ನಾವು minus x ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. So in the right side ತಗೊಂಡ್ರೆ plus x, left side ತಗೊಂಡ್ರೆ minus x, right? So ಇದು ಗ್ರಾಫ್, ಈ ಗ್ರಾಫ್ ಕೂಡ ಇಂಪಾರ್ಟೆಂಟ್, ನೆನಪಲ್ಲಿದೆ, right? ಗ್ರಾಫ್ ಫಾರ್ ದ ಫೋರ್ಸ್ ಅಂಡ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಸೊ ಇದು ನಿಮ್ಗೆ ಇಷ್ಟ ಇದ್ರೆ ಬರ್ಕೊಳ್ಳಿ ಅಥವಾ ಹಂಗೆ ಬಿಡಿ. ಸೊ ಗ್ರಾಫ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಗೊತ್ತಿರಬೇಕು, ಏರಿಯಾ ಅಂಡರ್ ದ ಕರ್ವ್ ಯೂಸ್ ವಾಟ್, ದ ವರ್ಕ್ ಡನ್ ಆರ್ ಎನರ್ಜಿ. So in our next class we will discuss about conservative force and non-conservative force. Tumba important concept, right? We'll continue in our next class. Thank you.